Good day, viewers. You are welcome back to Tindanius Maths and Science Tutorials. You are welcome once again. Today is the last part of the differentiation of inverse trigonometry functions. So today we are going to consider the secant of a given function. So what I have, that's sec inverse of u. The sec here simply means secant of, the secant inverse of this. Okay, so secant, this is secant, of this. And I find the derivative of this with respect to x. We will have the differential of u, then all over the absolute value of the function, which is u, multiplying square root of the expression u squared minus 1. This is the formula. Okay, so it means when you have a negative u here, okay, when you take the absolute value of negative, you have a positive. Okay, so this absolute sign just just in case you have a negative sign, okay, it reverses it to the positive sign. That is simply the work of the absolute sign over there. Okay, so let's say when you have, find the derivative with respect to x of secant inverse of, let's say you have x to the power, let's say 10. Okay, when you want to find the derivative of this function, what are we getting? Using the normal convention or the normal norm. Remember, we said you equate the expression, okay, given equation to u. So you have what? X to the power what? X to the power 10. We've been doing this all the time, right? So if you are new here, kindly visit my previous lecture videos on tan inverse of a function, cos inverse of a function, as well as sine inverse of a function and their corresponding proofs. So u prime of this, using the power rule, we have 10x to the power what? 10 minus 1. So u prime is equal to 10x to the power what? 9. As simple as that. Then we also know that u equals x to the power 10. So when I square u, I have u squared, which is equal to, you also square this. So you square this, then you also what? You square this. So 10 times 2 gives what? X to the power 20. As simple as that. So having done this, we are going to substitute this into the formula. So therefore, I can say that d over dx of sec inverse of x to the power 10 is given by, remember we said u prime, right? The differential of u. And here we have what? 10x to the power 9. So I have 10x to the power 9. Then all over, now the absolute value of the function u. And here, this is u, right? On the question, we have x power 10. So I have x here, power what? Power 10. Then multiply the square root of u squared. What is u squared? Here again, u squared is x to the power 20. So I have x to the power 20, then minus 1. What can we do here? So this is the same as we have 10x to the power 9, then all over x to the power 10. Okay, then square root of x to the power 20 minus 1. So therefore, this is the same as 10 all over x. Why? You have x to the power 9 and you have x to the power 10. Okay, so when you cancel out, in other words, you can use indices, okay, yeah, to just simplify this. So you have x is repeating 9 times divided by x repeating 10 times. So the whole of this x cancels this, leaving no x here. So you have only x, that's 1x here. So this is x to the power 1. Just use law of indices. Okay, so you have 9 over x to the power 10. What do you do? The same base, they are divided. So you have x to the power 9 minus 10. So I have x to the power negative what? Negative 1. Using the law of indices, this is the same as what? 1 over what? Over x. That explains why you have what? X here. Alright? Then you have square root of x to the power 20 minus 1. So therefore, our final answer is 10, then all over the absolute value of x multiplying square root of x to the power 20 minus 1. Viewers, this is the end of derivative of inverse trigonometry functions. See you next time. So far as this YouTube channel is concerned, we are going to learn a lot. Bye.